similar to the dot product, the cross product of two vectors can also be related to the angle between them. So we have this theorem 4.4 here, which says that if A and B are three-dimensional vectors, then it's related to the angle between them by the relationship here. So the magnitude of the cross product A cross B is equal to the magnitude of A times the magnitude of B times sine theta. Right, so you see this is similar to the formula for the angle formula for the dot product, and except now involves the cross product and sine instead of cosine. So again, we're not going to verify this theorem here, but you can sort of verify it by expanding out the calculation in terms of the components. And so there's a few uses of this formula here, right? So basically, if two vectors are parallel, then the angle between them is either 0 or pi, and sine of 0 or sine of pi is both equal to 0. So that tells you the magnitude of the cross product is equal to 0. And if the magnitude is 0, the cross product has to be the 0 vector, right? So basically, this is a way of calculating and determining whether two vectors are parallel. So you calculate the cross product, and if the result is the 0 vector, then they're parallel. So parallel just means that there's a couple ways of thinking of parallel. That means either they point in the same direction or opposite directions. And in terms of the components of the vectors, it just means that one is a scalar multiple of the other. So that's how you typically want to think of parallel vectors, right? So they either point in the same or opposite directions, and in terms of their components, one is just a scalar multiple of the other. Okay, so we're also going to apply this formula here and use it to calculate the area of a parallelogram, right? Because basically, if you arrange the two vectors in this way, so A and B, where the initial point for the two vectors is the same, right? So this is important here. So the initial point is the same, so that the two vectors form a parallelogram, right? So this side is parallel to this side, and this side is parallel to this side. Then the area of this parallelogram, right? So the area of parallelogram is just equal to base times height, right? But what is the base? The base is the magnitude of B, and what is the height? It's this side here, which is magnitude of A times sine theta. But this calculation here is exactly part of this formula here, and it's the same as the magnitude of the cross product. Okay, so this calculation allows us to calculate the area of a parallelogram when the vectors are arranged in this way. So we're going to take this idea here and apply it to example 3 on the next page. So in example 3, we're asked to, we're asked to calculate the area of a triangle, not a parallelogram, with vertices P, Q, and R. So first of all, this is in three-dimensional space, so it's hard to visualize it. But let's imagine we're arranging the points P, Q, and R in some arbitrary way. So let's say like P is there, Q is maybe somewhere there, and say R is somewhere there, right? So the 3 points form the vertices of a triangle, so that's what we're interested in, right? So this area here, however, we can relate it to a parallelogram by just so taking this side and extending it like this, and then taking this side and extending it here. And so this is not very exact, but this triangle and this triangle are supposed to be exactly the same, and so 2 copies of the triangle arranged in this way forms a parallelogram. So basically the area of the triangle PQR is equal to 1/2 the area of the parallelogram. So that's how we're going to do the calculation. So now to do the calculation, all now I need to do is do a cross product. So how do I set up the vectors? Right, so I need to set up the vectors so that the initial point is the same. So let's say I can start P is the corner, and take the vector from P pointing to Q and also from P pointing to R like this, right? So again, I need the initial point the same. Which I do when it's set up like this. So now I can write down my vector. So what is the vector PQ? So it's just the difference of the coordinates, right? So that's -3 minus 2, comma 2 minus a -2, comma 3 minus 1. So just calculating this is -5, comma 4, comma 2. And doing the same for P pointing to R. So it's just the difference of the coordinates. So R minus P, right? So 3 minus 2, comma 3 minus a -2, comma -2 minus 1. Okay. So calculating this is 1, comma 5, comma -3. Okay, so now I have my 2 vectors, and I'm ready to calculate their cross product, right? Because the cross product is the area of the parallelogram. So, so their cross product, so PQ cross PR. I set up the determinants, so I hat, J hat, K hat. PQ goes in the second row, so that's -5, 4, 2. PR goes in the third row, so that's 1, 5, -3. And then I expand this. So first term I hat, the 4 entries are 4, 2, 5, -3. Second term has a minus sign. For J hat, 4 entries are -5, 2, 1, -3. Third term has a plus. The entries are -5, 4, 1, 5. And it's for K hat. Okay, so now proceeding with the calculation. So this is 4 times -3 minus 2 times 5, right? So again, I'm just doing the AD minus BC minus this -5 times -3 minus 2 times 1 plus -5 times 5 minus 4 times 1 K hat. Then calculating each of these. So -12 minus 10 is -22 I hat. This is 15 minus 2 is 13, but this minus makes it -13. And then plus -25 minus 4 is minus 29 k hat. Okay, so this is my this is the cross product, but I still need to this is the cross product, not the magnitude yet. So now I need the magnitude of this. So the magnitude of PQ cross PR is the square root of negative 22 squared plus negative 13 squared plus negative 29 squared. And so what is this equal to? Okay, so when I square a negative, it becomes positive anyway, so I can just calculate this as 22 squared plus 13 squared plus 29 squared. So I get 1494, and then the square root of that, so square root of 1494. Okay, so that's the magnitude of this. However, that's the area of the parallelogram, and I need the area of the triangle. So the area of the triangle is equal to 1/2 of this. Which is approximately equal to the square root of 1494 out of the square root, the whole thing divided by 2. It's approximately equal to 19.333261. Okay, so that's the area of the triangle.